Newton's third law of motion. Whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body. Every action has equal and opposite reaction. Examples to illustrate Newton's third law of motion. How do we walk? When we walk on the ground, our foot pushes the ground backward, and in return, the ground pushes our foot forward. Why the cannon recoil? When ball is fired from a cannon, the force sends the ball forward and is equal to the force sending the cannon backward, hence the cannon is said to be recoiled. Jet aeroplanes and rockets. The action of the gases downwards of the rocket gives equal and opposite reaction to the rocket to move upward with great speed. The case of hose pipe. The fireman directs a powerful stream of water. They hold it tightly because it has tendency to go backward due to the backward reaction of water rushing in forward direction. Law of conservation of momentum. When two or more bodies act upon each other, their total momentum remains constant when no external force exerts on it, is called law of conservation of momentum. Momentum is never created or destroyed. It is also called principle of conservation of momentum. Let two objects of mass ma and mb traveling in the same direction have initial velocities as ua and ub respectively, and their final velocities be va and vb respectively. The rate of change of momentum of ball A be FAB, which is equal to ma into va minus ua upon t. The rate of change of momentum of ball B, FBA, is equal to mb into vb minus ub upon t. According to the third law of motion, every action has equal and opposite reaction. Hence, the force exerted when both objects get coiled is FAB is equal to minus FBA. On solving, we have MAUA plus MBUB is equal to MAVA plus MBVB, where MAUA plus MBUB is the total momentum before collision and MAVA plus MBVB is the total momentum after collision. The sum of the momenta of the two objects before collision is equal to the sum of the momenta after the collision when no external unbalanced force acts on it. Momenta is the plural form of momentum. Did you know Sir Isaac Newton sought to describe the motion of all objects using the concepts of inertia and force, and in doing so, he found that they obey certain conservation laws. Equilibrium occurs when the resultant force acting on a point particle is zero. In systems where objects are moving with different velocities, it is impossible to determine which object is in motion and which object is at rest. In other words, to phrase matters more technically, the laws of physics are the same in every inertial frame of reference, that is, in all frames related by a Galilean transformation. Weightlessness when in free-fall orbit around the Earth and Newton's law of motion are more easily discernible in such environments. Summary. Let us summarize what we have learned. First law of motion. An object will be in the state of rest or in motion until external force acts on it. The mass of the object is a measure of inertia. Force of friction always opposes the motion of objects. Second law of motion. The rate of change of momentum of the object is proportional to the unbalanced force in the direction of force applied. The SI unit of force is kilogram-meter per second square. Third law of motion. Every action has equal and opposite reaction. The total momentum is always conserved.